I'm gonna do this small video. It's to show you that I know what I'm doing in electronics. I know what I'm doing with communicating with processors. I've been doing that for a long time. It's just everybody's held me down and lied about me and done bad things to me the whole time and held me down. You basically paid me $26 an hour for almost, I don't know, 12, 13 years straight. Held me down, where everybody's getting new cars, new houses, and you held me down and lied to me the whole time. Lied to me. Um, so basically, what I'm going to show you is how to communicate with a computer memory map. Basically, what it does is it has a whole bunch of it'll have a register and it'll have a lot of bits. Each bit has a certain function. You can use it for resolution, better graphics, better sound. You also use it to turn things on and turn things off. Let's say you want to turn your AC on in your car. Well, you normally you flip a switch, or push a button, turn it on. Well, that button connects to something and it turns it on. Maybe it goes to the computer register. It probably does because everything is a CPU. It goes to the CPU in the car now. I mean, I don't know what the car actually, how they actually do it in the car because I've never done it. Configured it. I don't know how they built the car. What I can say is, if you were using a CPU, it would be connected to a bit. You'd say, do I want to turn AC on off? You press the button, it would put a voltage on there on that, and it would select a certain bit and it'd write to it and say, turn the AC on. It'd be a 1 or a 0. And I'm going to show you how that's done in a processor. So basically what I just told you is this little function right here. It writes ones and zeros. And when you write to a computer processor, you use hexadecimal data, and it's a way of writing a lot of data at one time. A lot of ones and zeros all at one time, and I'll show you that. It's not very difficult. I took a few seconds to just create what would a control register would look like. Basically, what it is you have a bunch of functions, and you either turn it on or turn it off, or you change the resolution. Like you have a least significant and a most significant bit, and this would give you, 8 different options for the windshield wiper delay. You know, slow, a little bit faster, a little bit faster. Give you, you know, 8 different options for delay, and it's 8 because it'd be 0. That'd be the first, which would be the slowest, and then you put a 1 here, then a 1 0, then a 1 1, then a 1 0 0, 1 0 1. It just keeps adding up. You have 8 different options, 0 through 7. Um, that's how it adds in binary because these numbers can only be 0 or 1. It's just 0 or 1. And now I'll show you how easy it is. So um, if I just wanted to turn the AC on, I put a 1 there. If it's raining and I want the windshield wipers on, I do it here. Um, I'll go ahead and put the delay on, and I'm going to have it as fast as it can go, like that. There's no ejection seat, but I'm going to have the Wi-Fi on. And the reason I have this is because people do that to me. The remote braking. Someone pressed the button when it's up by Glen Rose on a back road somewhere. I go by a sheriff's house. All of a sudden, the thing goes beep, 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 and somebody hit the brake. It wasn't me. The car almost stopped as I was going down the road. So, whoa, something's wrong with that. And I felt somebody, tug on the steering wheel one time when nobody was in the car. I mean, I was driving, but nobody grabbed the steering wheel, just started pulling. That's not a good thing. That means you got a kill switch somewhere too, so you could just kill the car while I'm sitting on a railroad track somewhere, right? But here you probably got an ejection seat somewhere, and you might have something where I don't know it has a spike that comes out of the steering wheel, hit me in the head. I don't know. You could have done anything you want. I have no idea. But then you have a tire change, pressure settings, and the reason I have three bits for the change because what you can do is you can change the what they call hysteresis for where the alarm goes off. So if it's 1 pound of pressure below the setting, you could give an alarm for low pressure setting. maybe it's 2 pounds, so you'd have 2 bits. It gives you more resolution. The more bits you could use these bits for it. You give yourself a whole lot of resolution for the tire pressure change. It depends on how sensitive you want it to be. It just gives it more bits, gives you more resolution. Or you could have just 1 0 to turn it on or off, like a switch. The dongle, you can turn it on or off, or you can clear the history. So now that I put these numbers in here, I mean, I have these numbers up here. These are all 0. So what you would write to a computer register would be, this would be 8. This would be 8. This would be 7. This would be C, and a 2. 2. I'll type that up for you really quick. 1 second. First, I'm going to have to manipulate things here. I should have done this a second ago. I just didn't do this. Just do it like this. That. Copy. That. Okay. I got that. So this would be an 8. And this would be a 7. That would be a C. Only about 2 seconds over on that. And this would be a 2. 2. 2. And I'll make the numbers larger so you can see them. So this, I'll make them larger. And I'll make them bold. And how I add that up is your least significant bit. That's your most significant bit. I'll show you how to convert this. I mean, I know how to do this because I do it all the time, and I'm going to show you an easy way of how to do it. This is, you can decode the wall that the code that I put on the wall is real easy too. If you have a computer with a calculator, I mean, I'm sure you already know that. You probably ought to figure that out. So I'm going to pull up a calculator real quick and just do it on engineering. That way I can it automatically converts hexadecimal to binary into decimal stuff. So I'll just pull up a calculator. Later. It's already set for programming. You can change the settings here. I got it set for programming. And I'll just do it the easy way. I'm going to do it in hex. I'll say 87C. The last number was a 2. 2. So 87C2, which is what I have here. 87C2. And you see the binary representation is 1000, 0111, 1100, 0010. So that's hexadecimal, that's binary. If you want the decimal number for it, it's 34,754. I can show you the math. I know how to do the math. I'll show you. It's real easy. I'll show you real quick how you do the math. You just do it with the binary conversion to hexadecimal. So to do that, I'm just going to add some cells in here. Here. I'm just going to add some cells. Insert, insert again. Okay, and what I'm going to do is I'm going to add representation on here so you can see what it actually represents. Merge, do that. Showing you how to convert to decimal. So this bit represents 1. I'm going to change these so you can see what it is. Keep them all equal. There we go. 1. This will represent 2, 4, 4, and 8. 8 like that, and they all do the same. So let's copy this and that. 1, 2, 4, and 8. The highest number you can have is F. In hexadecimal is F, but F represents the number 16. I'm sorry, 15. 15. You have 16 numbers, 0 through 15. F is 15. All ones is 15. 0 is 0. And I'm going to show you how to do that real quick. It's real easy. So what I'll do is I'll just clear this out. I'll say 0. Oh, actually, I'll go ahead and leave that back how it was, and I'll show you how I got 8. So 1 is on 8. The rest of these are 0. So it's an 8. It's 8. This is 0, 1, 1, 1, 1. It's 7. 1 plus 2 is 3. 3 plus 4 is 7. It's easy. So it's 4, 5, 6, and 7 because all those are high. These two are high. 8 and 4 is 12. C is a representation of 12 in hexadecimal. So you go 0 to 15. C is 12. The only bit high is the 1 right here for the 2. So it's a 2. If it would have been a 1, 1, this would be a 3. But it would mean you just turn the ejection seat on to kick me out of the car. I showed you that. I'm gonna show you this. This is real easy. 0, 0, 0. So if this is high, it's a 1. That means in hexadecimal it's 1. Then it would go here, and this would be 0, and that would give you 2. And this one would go high, and it just keeps going, incrementing. And this would be a 3 because you add them together. 2 plus 1 is 3. Then the next one would be a 1. These would be zeros, and that would be a 4. Oh, 4. See how it keeps adding? Then this one and this one would be a 5. Then it would be 1, 0, be a 6. Then it would be a 7. Then it would be 1, 0, 0, 0. That's 8. And it just keeps adding. Here's 9. Then it would be 0 and 1. And that would be 10, but 10 is equal to A. And the reason I do that is because 0 through 9 is one column. So then you get 10, you increment over. So it's base 10. 0 is 0 to 9. It's 10 numbers, 0 to 9. Hexadecimal is 0 to 15. So you can't use 10, 11 because it would be increment. So they just use letters, a representation of numbers. So it goes 0 to 9. 10 is A, 11 is B, C is 12, D is 13, E is 14, F is 15. So you can see there's 10, so that would be an A. That would be an A. Then you'd have 11. So 8 plus 2 is 10 plus 1 is 11, so that'd be a B. Then you'd have a C, which would be 12. 8 plus 4 is 12, so that'd be a C. You would have 1 here because you keep incrementing as you go, and that'd be a D. Then that would be a 1 and a 0, and that would be E. Then you would have all high, and that would be F. You call that all ones, but usually all ones means all of these would be 1. But we're just talking about this area. So that'd be a F, and that would be 8 plus 4 plus 2 plus 1, which would be 15. In doing that means all these bits would be on at the same time. Sometimes you can't do that. Now, what these are is called, would be called control registers because you're turning stuff on and off. You also have status registers, which tells you, what's going on in your car. I think it tells the computer what's going on. And then if it goes beyond a certain limit, then it'll set a flag or an alarm. You have alarm registers, status registers, control registers, and scratch registers. And scratch registers is how you just test if you can read or write to a computer, if it's working or not. But I can't do any of this stuff because you guys won't tell the truth. I can't get a job anywhere in the world because none of you want to tell the truth. You're just going to lie to my face again tomorrow. It's Groundhog Day. Thanks, guys.